Okay, so we already spoke about how to do arithmetic with imaginary numbers. Now we need to speak about how do you do arithmetic with complex numbers. Okay, so like I said, it's exactly the same as everyday arithmetic. So the only difference is whenever we see an I squared, we have to keep in mind that that should be replaced with -1. But everything else is more or less the same. So your standard operations work exactly as we expect. And so let me just show you what I mean. So here, let's have a look at part A, right? So in part A, I want to figure out z plus 2w, where z is the complex number 3 minus I, and w is the complex number 4 plus 2I. So, pretty simple. I'm going to get 3 minus I plus 2 lots of w, 4 plus 2I. Now here I've got to expand brackets, right? And I expand brackets exactly how I normally expand brackets. So this times this, 2 times 4 is 8. And this times this, 2 times 2i is 4i, leaving me with 11 plus 3i. So in terms of how I did that, it's all about adding like terms. So I can add reals to reals, so 3 plus 8 is 11. And then imaginary to imaginary. So negative I, adding 4 lots of I, obviously I get 3I. So you see exactly how you would expect. Let's have a look at part B. So I want to do minus 5z minus w. So we know that z is 3 minus I, and we know w is 4 plus 2I. Again, expand brackets in the usual way, so negative 15 plus 5i, negative 4 minus 2i. Collect like terms, so negative 15 minus 4, that's negative 19. 5i minus 2i, that leaves you with 3i. So fairly straightforward. Let's have a look at part C. Let me go to the next page. So in part C, I want to figure out z w squared, where remember z was 3 minus I and w was 4 plus 2I. Okay, so let's have a look. So now what I'm doing 3 minus I times 4 plus 2I squared. Now to square this, I can use the identity that the square of a sum that we use quite often, right? We know that this is a squared plus 2ab plus b squared. So using that, I'm going to get 3 minus I, so 4 squared 16, 2 times 4 times 2i, so that's going to be 16i. And then you're going to have 2i all squared, so 4i squared. But remember, we said that I squared is equal to minus 1. So what I get, so 4i squared is actually going to be negative 4. And so you're going to get 16 minus 4, which is 12. Right? And now you just expand brackets. So 3 times 12, 36. 3 times 16i, 48i, minus 12i, and then you have minus I times 16i, so that's negative 16i squared. But again, we know that I squared is negative 1. So you're going to get 36 plus 48i minus 12i plus 16. Now we collect like terms, so 36 plus 16 is 52, and 48i minus 12i is 36i. And that's how that's done. So, as you can see, very straightforward. I guess the only one which is not so straightforward is division, because that has a certain trick to it, but once you see it, that will become very straightforward as well. So the question is, so part D, how do you do a z divided by w? In other words, how do you divide complex numbers? Because, of course, I could just write this, 3 minus I over 4 plus 2i, but that's not really in the form of a complex number. So the question is, how do I take this and write this in the form of a complex number? Okay, so the trick is, in this case, you multiply this by this particular fraction. Okay, so you can see that this is a valid thing to do because the numerator and denominator of that fraction are the same. So that fraction just equals 1. So essentially what I'm doing is I'm just taking the original expression in black and I'm just multiplying it by 1. So I'm not changing it. So I'm not doing anything which is not valid. Okay, but as you will see, this will actually take z over w and give it to me in the form of a complex number. So let's have a look. I get on top 3 minus I, 4 minus 2i, and on the bottom I got 4 plus 2i, 4 minus 2i. Okay, so on the top, if I expand brackets, I get 12 minus 6i minus 4i plus 2i squared. Now on the bottom, notice I have a difference of 2 squares. This is the denominator is in the form of a plus b, a minus b, right? So it's in this form, a plus b, a minus b, which, remember, gives you a squared minus b squared. And in fact, that's how you decide what that fraction in pink should be. So when you're deciding what should you multiply by, you want to multiply by something to get the difference of 2 squares on the bottom. So because the bottom was originally 4 plus 2i, I multiplied it by 4 minus 2i to get the difference of 2 squares. And the reason behind that is because now this will make the denominator real. Because you see what I'm going to get? I'm going to get 4 squared, which is 16, minus 2i all squared. And that's going to be a real number. So on the top, I got 2i squared, which remember is negative 2. So I get 12 minus 2, which is 10. And then minus 10i. On the bottom, 2i all squared is 4i squared, which is negative 4. So really you get 16 plus 4, which is 20. And so this can be written as 10 on 20 minus 10 on 20i, or in other words, a half minus a half I. So that's the trick for dividing complex numbers. Now, this guy here, right? Let's talk a little bit about this guy here. So I mentioned I went with 4 minus 2i to get the difference of 2 squares on the bottom, right? This 4 minus 2i, this is called the conjugate. The conjugate, so that's a very important term. The conjugate of 4 plus 2i. And the notation for it is this. So you take 4 plus 2i, and you put a little bar on top. This equals 4 minus 2i. So when you put that bar on top, so the way you would read this as the conjugate of 4 plus 2i is 4 minus 2i. So what the conjugate means, it really means you just take the imaginary component and you flip the sign. So if it's positive, like in this case, I had positive 2i, you make it negative. You make it negative 2i. Or conversely, if it was negative 2i, you'd make it positive 2i, right? This operation is called conjugation. So 4 minus 2i is called the conjugate of 4 plus 2i. So when you try and figure out what this fraction is that you want to multiply, so it's very simple. You just take the conjugate of the denominator and basically you put that on the top and the bottom of your fraction. And that will pretty much solve it for you. And this is how you divide complex numbers. So just to recap, right, the conjugate of a complex number z equals x plus iy is x minus iy. And like I